Hello, my dear grade 9 learners. We are now down to our last video lesson in basic trigonometry. Once again, I am Teacher Bless and I am here to help you understand your lessons. In this last video lesson, we are now going to solve real-life problems involving right triangles. Are you ready? Come on! Let's solve first our lesson objective. We have here, use the trigonometric ratios in solving real-life problems involving right triangles. I prepared two problems involving right triangles and we will be having it one at a time. Let's consider the first example. An 8-meter ladder is placed against the wall of a principal's office, and it reaches the topmost. If the angle of elevation of the ladder to the top of the office is 45 degrees, what is the height of the principal's office? Take note, in our video number 2, if you're given with a word problem, the first thing that you're going to do is to illustrate the situation. Now, in our problem, we have our principal's office and we have also a ladder. Suppose that this is your principal's office. And accordingly, there is a ladder that is placed against the wall. Now take note, your ladder reaches the topmost part. So suppose that you have here your ladder. Now, in our problem, what is the given measurement of your ladder? That is 8 meters. Take note, you are also given with a condition that the angle of elevation of this ladder to the top is 45 degrees, meaning this angle here that is formed is 45 degrees. Now, the question is, we are asked to find the height of the office. So you have here, from this point to the ground. So this is our missing side. Now, if we let n to be that missing side, as you can see here, we are able to make a right triangle. Now, if we let this angle here to be our angle of reference, what side is n and what side is 8m? This is your n. This is your opposite. How about the 8m? This is your hypotenuse. Now, you're looking for the opposite and you're given with the hypotenuse. What ratio then are you going to use? Is it the sine, cosine, or the tangent? That is your sine ratio. So we know sine ratio is equal to opposite over your hypotenuse. Now, since we let this angle to be our angle of reference, so we replace our theta here with 45 degrees. So you have now sine of 45 degrees is equal to opposite. That is your side n, which is the height of your principal's office. So you have here n over your hypotenuse, which is 8 or 8m. So let's now solve for the value of your n. So we can cross multiply. Take note, we have here invisible 1 denominator. So let's cross multiply. 1 times n, that is n. And then 8 times sine 45, so we can place them side by side with each other. You have 8 sine of 45 degrees. This time, you are now going to use your calculator. So let me get my calculator. So you have here, so all we need to do is to input 8 sine of 45. So we have here 8, and then you have here sine ratio, and that is 45 degrees. And then we press equal. So that is 4 square root of 2. Or you can also transform that one in decimal form by clicking SD. So you have here n is equal to 5.65 and something. So let's round it off to a whole number. So since you have 6 here, this is estimated as n equals 6. And the unit of measurement, this is m. Therefore, the height of your principal's office is approximately 6 meters. Is that clear? I hope so. Let's consider the second example. So you have here this garden. So I know you're familiar with this because we have our gulayan in paaralan. So try to read. We have here, the school's gulayan garden is subdivided into small rectangular lots. Find the area of one of the rectangular lots given the conditions that follow. Okay, so this is your condition here. Okay, this triangle below. Now you're given with the condition that this side here is 1.2 meters. And then you have here this angle which is 24 degrees. Now take note, what are we looking for here? We're looking for the area. Now when we say area, take note in our problem, we are given with the clue, rectangular lot. So your lot is a rectangle. Now what's the formula for the area of a rectangle? That is your length times the width. Now try to check your given illustration. Do you have your width? How about your length? Alright, as you can see here, we have only our width, but we don't have our length. Now, as you can see here, instead of length, we're given with this angle, which is 24 degrees. Now, if this is our width here, we are going to find first our L so that we can get our area. Now, if we let this angle to be our angle of reference, 24 degrees, what side is 1.2 m and what side is your missing length? This is your opposite. And then this one is your adjacent. Now, you're given with the opposite and you're looking for adjacent. What ratio then is applicable? Sine, cosine, or tangent? This time, this is tangent ratio. So you have here, tangent ratio is equal to opposite over your adjacent. So here, we replace our theta with our angle of reference, and that is 24 degrees. So you have tangent of 24 degrees is equal to opposite. You have here 1.2 meters, or you can just write 1.2 over your adjacent. We don't have our adjacent measurement, and we represent that with L. So you have here over L. Let's now solve for the value of L. Let's cross multiply. So we have here once again invisible denominator, which is 1. So let's have L times tangent of 24 degrees. This is L tangent of 24 degrees. And this is equal to 1 times 1.2. This is 1.2. Now, since we're looking for the L, what are we going to do to isolate L on the left side of our equation? We are going to divide. So, we are going to divide both sides by tangent of 24 degrees. So, this is gonna be canceled out here. So, what's left? You have your L. And then this time, we are going to input this in our calculator. So, let me show once again my calculator. So, you have here, we need to refresh first. So, you have 1.2 over, you have your tangent ratio, this one, 24, and then you have here degrees. And then you close, and then you click equal. Okay, so that is equal to 2.69 and something. So you have here L equals 2.69 and something. So let's round it off to a whole number. So since you have here 6, so this is gonna be L is approximately equal to 3, and then the unit of measurement, this is in meters. So you have now your length. So we have now the length and the width. Therefore, we can now get the area of this rectangular lot. So we have area equals length times the width. So A equals, we replace L with our measurement. That is 3M. So you have here 3M times the width, and that is 1.2 m. So we have here times 1.2 m. So you have now A equals, this time input this in your calculator. So you have here 3 times, you have 1.2. So you have here, click equal, you have here 18 over 5, or this is equivalent to 3.6. So you have here 3.6. Now take note, this is an area. So what would be our unit of measurement? Okay, we can simply multiply m and m. So that is m times m, you have m squared or square meters. So we have here our area, that is 3.6 square meters. Alright, that's it for this video lesson about solving problems involving right triangles. I hope you've learned from this video. Feel free to play, replay, or pause for you to understand your lessons better. I hope to see you all in our post-test next week. Goodbye everyone, and have a great day ahead.